know your name.
Now don't speak in. Okay.
Okay, everybody, let's move on. So let's welcome our next presenter, Elvir Kuric, who is a member of the performance engineering team at Red Hat, and he's going to tell us about building an Openshift cloud on RHEV. Welcome, Elvir.
Thank you. So thank you very much for joining us this morning. As Evgeny told, the presentation is going to be about how we in the performance team build a Openshift cluster on the top of RHEV, and how which problems we faced, how we solved them, and we are going also to show. I'm going also to show the ideas how you can build it yourself in your environment. So in this talk, I'll talk a bit about motivation. Then we'll say about hardware which was used for this installation. Also, I'm going to say about how Openshift was built on top of RHEV. I mean the complete process of building RHEV virtual machines. Then feeding that information inside the Ansible playbook and how Openshift was installed, and later on for the test how we created 20,000 pods on the top of this Openshift installation. Then I'm going to follow explaining the critical places which I faced during the installation, where I spent quite a lot to fix them, just to understand why they are happening and how to avoid them. Is the level of sound I'm giving good enough, or I should? Okay. In the previous talk, it was mentioned that it is good when you have someone to call at 3 a.m. To give you support on a particular problem, and this is for example, one of motivation reasons could be we can build Openshift on top of RHEV, and that is fully supported. If you are a Red Hat customer, that means a lot. So that could be one reason for as motivation for this problem. Second case was a build open container platform on the top of RHEV, because you can find documents explaining how to build it on the cloud, on the Google Cloud, on the Amazon, on the OpenStack. But on the top of RHEV, I did not found, maybe I didn't look at the right places. And this could be particularly interested for the people and the customers who wants to use Openshift and all its features it offers, but at the same time, they don't have enough skills and knowledge to build it on the top of OpenStack. So a lot of people are skilled in the traditional virtualization technologies like VMware or RHEV. I say traditional, that means a bit older technologies than OpenStack, and learning about OpenStack and building Openshift on it could for them be a bit problem. It was also the project task within the performance team, where we wanted to build an environment where we can start as many as possible pods for another project. It is related to the Openshift metrics, and tomorrow 1 p.m. with my colleague Ricardo, we are going to talk a bit more about that. So, and once the cluster was built, the number of pods which we planned to schedule was around 20,000, and we wanted even more, but but we were limited for the project with specific bugs, and it doesn't make sense for us to go further. Okay, this is the hardware I use for this configuration. It was a pretty good hardware, I think, except this red line, this storage backend, which obviously were not good enough to support the number of virtual machines and pods created. In total, I had 19 hypervisors as a part of a RHEV cluster, totaling about 2.5 terabytes of RAM and 688 cores. Every hypervisor had two network interfaces, one 10 gigabit and one 1 gigabit network interfaces, and 10 gigabit network interfaces was taken from every hypervisor and put into the logical network. So the whole Openshift communication were happening over that 10 gigabit network interface. As a storage, I use the iSCSI storage domain on RHEV, and all virtual machines were using it. Storage backend, I mean the hardware, was VNC 1600 from EMC. Not the best solution, I think. RHEV installation, I guess this is not something new. Kickstart RHEL, and on top of RHEL, build RHEV. I follow the path where I use RHEL and then added the RHEV packages on top of it. Other option, I think it would be possible also to use directly RHEV ISOs and follow that path of RHEV installation. Once the RHEV is installed, storage domain configured, and logical network configured, and all in place, then it is necessary to find out some way to create virtual machines itself on that RHEV environment. And without API, it would be really hard. So here is an example how I did. I use the Python over SDK. I'm pretty sure there is a million other ways to do it smarter, better. What I was doing is, if you open that link on the GitHub, you'll find there is a script which enables me to create X number of virtual machines with X virtual CPUs and Y gigabytes of memory, and at the same time attaching that machine to the specific RHEV network. So, and I was creating one machine at a time, starting it, and then creating the next one. I could do threading and stuff and create everything in parallel, but I'll tell you reason why not do that a bit later. Okay, so when creating virtual machines, if you don't say it specifically, RHEV is going to create virtual machines on the sparse disk. So that saves the storage space. That means if you create virtual machines of the size 30 gigabytes on the sparse disk, in reality, on the backend storage, that doesn't mean you occupy that size completely, because it is occupied over the time. Second option is to use a pre-allocated storage for the virtual machines. In my test, I noticed that using the sparse storage type for virtual machines is quite problematic for masters, etcds, and routers, especially for etcds, because etcds are quite sensitive to the delays, and at the mass pod creation, it led that I have problems with etcds. So, pardon. So I put my etcd machines masters on the pre-allocated storage disk. OpenShift nodes were on the sparse storage type, so I didn't change that. When using API, it's necessary specifically to say disk params clone true. The minus is it is going to allocate the space in advance. You will not have flexibility. The first minus. The second minus is the creation time of virtual machine. For example, if you want to create one virtual machine with a pre-allocated storage disk, that is going to last directly proportional to the size of the virtual machines, because it needs to do the complete cloning in the background, the storage. And at the size of 200 machines, it could cost quite a lot of time. Okay, this I mentioned already. So in this specific cluster, I had 3 masters, OpenShift masters, 3 etcd servers, 1 router or load balancer, 7 infra nodes, which I was using for infra pods. That means router, registry, then logging and metrics pods. And the rest of 210 nodes were reserved for usual application pods. In total, I had 224 machines in the cluster. In this specific configuration, etcd servers were not on the same boxes as OpenShift masters, and reason for that, I think it is good to divide these machines. Though there are different opinions, and with the different, I'm discussing with different people, and people think, okay, if you remove them, if you divide them, then there is a network latency problem. Could be network latency problem between OpenShift masters and etcds. But at the same time, that gives you flexibility. That means you can, if you lost the one machine, you are just losing, in case they are together, you are losing etcd and the master. At the same time, if they are divided, then you have a bit more space to breathe. And there is another problem. There is Bugzilla, was opened a couple months back by me. It is a situation that on the OpenShift machines, with many pods, it happens that IP tables and IP tables restore are causing high CPU usage, and that is a particular problem for the case when there are many pods. So that Bugzilla is still present. So I noticed that problem on my etcd machines, and when they were part of together with masters. So that is one of the reasons why I go with this. Load balancer was self-standing box. Also, masters were not schedulable, and on the infra nodes, that is our recommendation to have, say, dedicated nodes for the infrastructure pods. So I created special nodes just for running these pods. In, I would say, in 3 steps, it could be create virtual machines. Then there is an addition to this also to collect IPs and VMs when machines are created. That means once you have machines, you need some way to collect IPs in order to feed them later on in the Ansible playbook. And last option, use Ansible, OpenShift Ansible to build it. Yeah. When I first tried to install this, because I tried multiple times, I naively created a golden image in the RHEV, but I made a mistake where I packages, and when you just put the bare rel and create repositories properly. That means it is going to download all packages during the installation. That works fine for 5, eventually 10 machines. But when you have 220 machines, then that doesn't work fine. And that first installation try lasted, I don't know, 7 hours, and I went home because it was downloading everything. So that was my mistake. So next thing I did was I increased the CEP forks, CEP for Ansible forks in the etc Ansible config. Default is 5, but I bumped it to 10 because just wanted to get a bit more Ansible forks running in parallel. And then I went back to my RHEV template, and based on my previous experiences with Ansible and Openshift, I realized that it is going to do all stuff in parallel on a lot of machines, downloading packages and so on and so on. And then I downloaded NFS, Gluster, CEP, I think bunch of other packages, for example, PyYAML. Then I figure out in the Ansible which booleans need to be on, or which booleans will be on after the OpenShift installation. And I did that in advance on the golden image. And after I did that all, once I repeated the installation, so with that reworked RHEV image, installation of 224 nodes lasted around two hours. So here is the main advice: put everything, as much as possible, data inside your golden image if you are installing big cluster. Are there some questions at this time?
Yes, sir.
Yeah.
So what storage was used? Like, what was the disk on each of the nodes for Docker storage? Was there secondary disk for pod storage, or they used local disk?
Okay. The question was what storage was for the Docker inside the virtual machine, I guess. Yeah. So I was using. There was no special additional disk like DevSDB inside the virtual machines. I was using device mapper, and it was built on the top of root logical volume on the top of root partition. So it was inside, but there was no special DevVDB. No, that was not the case. One more time, please.
When it was downloading the packages and it was taking that long, the 200 nodes, was that off the CDN or off the local mirror?
Local mirror. I mean, I wouldn't do that. The question was from where I was downloading the packages during the installation for the case when it lasted 8 hours. From the local mirror. I mean, it would be quite unusual, and I would say stupid to do that against the CNN. Content network. So yeah, it was local, inside, maybe a couple meters away. Okay, so then for another project, I needed I needed as many as possible pods. I mean, I just needed number of pods, no matter what kind of pods are, because I wanted to collect memory, CPU, and network numbers. And I decided to create 20,000 pods on the top of this cluster. And in the performance team, we have a cluster loader tool. You have a link here. There could be possible to do separate presentation for the cluster loader because it is a big project. And so in the nutshell, it does, you specify the number of projects you want, and then you specify in the YAML file, you specify the number of pods you want per project, and based on which image, and run it, Python. And after some time, it's going to create you that. it was necessary to change. By default, you have a pods per core is 10 pods per core. So in this configuration, I had to change pods per core 0 to allow more than 10 pods per core to cover the defaults. Yeah, so no special requirements on the pod type. I just wanted them as much as possible. Okay. So lessons learned. Try to get quite fast storage backend. That means hardware. This one I used, its specification says it's entry-level storage backend, storage from EMC. I mean, it's probably fine, but for the number of virtual machines, like for example here, it was causing me quite a lot of troubles. So then etcd must. Yeah, sorry.
How many paths, and did you use iSCSI bonding against the storage?
Just iSCSI with jumbo frames. But I had the 4 paths. I mean, it was multi-pathing over iSCSI. Yeah. The question was how many paths we're using from the hypervisors to the storage backend. etcd masters and infra machines, I think they should be on the pre-allocated storage disk when running in RHEV. If you ask me now how this is for the OpenStack case, I cannot really answer that. And etcd is quite sensitive on delays. So, yeah, this one. If you find in the etcd logs an error message like this, it is say, okay, etc service is like overloaded. And I have seen this before I moved to the pre-allocated storage disk. Then I first thought, okay, it is the network problem. But I have 10 gigabit network problem, and I never seen that nodes are going to the not ready state. So that was not excluded. Then in my disappointment, I said, okay, let's move var lib etcd for the test just to the dev smhe shm, so just in the memory, put and see will the issue happen again, and it worked fine. I mean, I never seen this. I mean, it was just test. I recreated everything on the pre-allocated storage disk, and it was better. On etcd machines, I think it is not necessary to run open atomic OpenShift master or node or Docker services. So you can, even they are not schedulable, OpenShift masters are going to pull them for the status. So that is just an additional load on them. And it happens sometimes that on the time when the virtualization is not playing the best, so ensure it is in sync in case it is not. It should be, but just ensure. Once you see this problem, if you see, you'll realize, okay, this deadline exceeded for 1.7 milliseconds, and you'll go probably to the etc etcd, etcd-conf, and try to play with these election timeout, election Herbert interval parameters, and get disappointment that is not going to help you, because that's just going to slow down complete cluster, to slow down the complete process of pods creation. The original values are 5 milliseconds and 2,500, but if you change these, the complete process of pod creation is going to be slower. And this error message I found that particularly could be reason in the storage or network or both. So in this case, in my particular test case, it was storage, but it can be also the network. Check this documentation of the CoreOS, that they have nice advices there. Okay, So I have also noticed that there is when you work at the customer site and install this everything, and then they say, okay, that's fine, that works all, but let's shut down everything and power it on. I mean, that happened to me a couple times when I was working for telecom. So you need to power down everything, and they're just thinking we want to relocate it everything 200 kilometers. And once I did that, I shut down all my virtual machines over the API very quickly, and once they are all in the red state, I powered them again over the API very quickly. And that led that storage backend got hammered by 220 machines trying to boot at the same time, and some of them did not boot it properly. So I think if I had better storage, that should not happen. But add there between the starting machines at least, let's say, 10, 15 seconds delay. So start one, wait, start another, and so on. And that's the reason in my script, I was using and creating one machine at a time and starting it immediately after creation. I could do that in parallel, and that would be probably a nice improvement, but it is not implemented yet. Okay. And this is an additional motivation for this, is that this is an example of completely Red Hat technologies playing together to build Openshift. So we have RHEL plus RHEV plus Open Container Platform plus Ansible to build platform as a service. Another solution would be to use OpenStack instead of RHEV. This presentation will be on the GitHub in a couple seconds. There are questions? Yes, please.
So you mentioned that with the pre-allocated storage, you used LVM thin provisioning as the backend for that?
That pre-allocated means just from the RHEV point of view. When
Yeah, I know.
Yeah.
That's like the QCOW image is pre-allocated.
Yeah, it's.
But did you have LVM thin provisioning below that? I think it was mentioned there.
Thin provisioning was inside the virtual machines for the Docker. I mean, the thin LVM. I mean, when you use a device mapper, device mapper storage plugin for the Docker for the Docker, then it uses thin LVM, and yeah, that is.
But the pre-allocated QCOW images were like
Yeah.
normal LVs.
Yeah, it was now.
But it's a contradiction. It's QCOW, not pre-allocated.
Huh?
It's QCOW, it's not pre-allocated.
Well, it's pre-allocated QCOW.
Yeah.
There is
I mean,
yes,
pre-allocate the space you are going to use if you don't have any snapshots and stuff like that. Like snapshots are allocated on but pre-allocates the
No, we're creating an LV 1 gig size, and if you need to extend it when you need it. That's pre-allocated.
No. This is thin provision. There is pre-provisioned to just allocate the full size of that space.
And then it's from QCOW.
It is QCOW still.
It's
You
QCOW.
can have a pre-allocated QCOW.
Yeah,
That's
pre-allocate.
how to use it.
Ah, okay. I didn't know that.
Okay, you had a question.
Thin provision on a block device, it's not pre-allocated.
Yeah, okay, first of all, thanks for the presentation. I'll probably ask you a lot of questions after it because I have the same exact task. But yeah, for example, how did it behave if, for example, there is 20,000 pods running and you shut down one master or one etcd? Did you test out these scenarios? Thank you.
I didn't. It was the question. The question was, did I test the environment when?
I used the microphone.
Okay. No, I did not shut down master or etcds for that testing because that was not a task. I mean, it would be good to see how that behaves, but I mean, I hadn't need for that, to be honest. But it should. I mean, there were 3 masters, 3 etcds, and if there is a problem with if we shut down one master, then that's probably issue for Bugzilla. So that is. Yeah, please.
Sometimes people use OpenStack to take use of, take advantage of the auto-scaling capabilities and the integration between Openshift and OpenStack. Have you had any opportunity to try or make benefit of the capabilities of RHEV with OpenShift? Or it was out of scope of your
Just a second. What capabilities? What specifically you mean?
if you have eventually evaluated if there was some automation or APIs that can be used for implementing some of the advantages that make people use OpenStack with RHEV instead to make more and more likely to be used to use RHEV instead of OpenStack.
So, like maybe using cloud forms with RHEV to automate scaling, like he does.
Mm, I think we cannot. These are different things to compare. I mean, OpenStack and installation on OpenStack, installation on RHEV. I mean, there will be always people who wants specifically RHEV, or for example, some virtualization, older type than OpenStack. I didn't investigate these, let's say, the points where what is if I understood correctly, what is better, RHEV or OpenStack? So I don't think we can compare fully them, my opinion.
But I think it would be interesting to test both scale up, for example, hot heading CPU and hot heading memory to the virtual machine, as well as adding more virtual machines. Now, I'm not sure you've mentioned that you've installed Openshift using Ansible. Now, I'm not sure how many people know, but RHEV does have Ansible models now in Ansible 2.2 and coming 2.3, so you could probably done the whole thing using Ansible.
Okay.
And then it makes it interesting to do all these actions we ask.
Yeah. You mean using Ansible to create virtual machine stuff?
Yes.
Yeah. I mean, there is probably, I would say, 10 different ways to do this way of creating virtual machines which are better than this one. So I'm not keeping exclusive right that this is the only one. So, yeah.
Last question. So, are you going to maintain this the work going forward, and what roadmap items do you want to do? Like, do you have a roadmap where you're saying we want to test this next and test that next?
PMs.
Okay.
This is just one of the OpenShift scale projects, right? And when we have certain time. Sorry. Yeah, so this is just one of many performance scale projects with OpenShift. This is OpenShift RHEV. And so we take from our program manager's input, so we can't always integrate all the cool things that are possible, but this is good feedback to give that feedback.
I think replacing the storage is the next milestone, right?
That would be excellent. That would be excellent.
We didn't even have a choice on
Actually, like I have
That would be excellent.
I
Please
have
do. Please do.
also like opinion from my side. What I've been testing also with virt, and actually storage is like a pain point major, and you don't actually need a centralized storage for running actually pods. They don't need live migration. They don't need like redundancy because you should use persistent volumes for that. So I was actually testing with local storage domains, which is actually disks of the hypervisors, and then you don't even have a central storage because it's a bottleneck anyways. Like as soon as you have a more powerful storage, you just double the number of pods, and then it kills it again. It just like this is the bottleneck. So what did you try this or not?
I mean, here is not problem with the pods, pod storage. I mean, persistent volume inside the pods. Here's the problem: the complete storage for the virtual machines. I mean, where virtual machines are. Here's the problem with that iSCSI storage domain. That was the problem. It was not. I mean, yeah, I can completely ignore storage for the pods and use the persistent volume and persistent volume claims and hook them to some, let's say, another storage somewhere. That would work as well. But the complete problem was with the virtual machine and the storage which we use there.
Thank you. More questions? We have a lot of time
Do
still.
you have more questions?
Yeah, okay then. Yeah, thanks a lot, Elder. We'll continue
Thanks for
after
attention. Just one more thing. Can I have just attention? No. Very much. Just invite them to tomorrow for the second.
And FYI, there will be a second part of this story tomorrow presented by Elver at 1 p.m. tomorrow.
it.